Hello everyone. Today I'll be giving a tutorial on hardware interrupts of MSP430. Interrupt is a signal that is given on the hardware pins. If it is a hardware interrupt, the signal can be a rising edge, a falling edge, or a level trigger. If the signal is rising edge triggered, then the signal must go from level 0 to level 1, and if the interrupt is negative edge triggered or falling edge triggered, the signal has to go from high to low. In MSP430, each and every pin of port can be configured so that it can receive interrupt. In other microcontrollers, for example like 8051, there are only two hardware pins. A processor like 8085 primitive old, there are very few hardware interrupt pins available. The more hardware pins you have, more multitasking or more functionality you can give to your application using the same controller. A little theory about interrupts. Whenever you receive the microcontroller receives an interrupt, context saving takes place. That is, the program counter is pushed onto the stack. Stack is like a scratch pad. It's generally located at the end of RAM. Once the program counter has been stored, the vector address of the interrupt that caused this context saving is loaded into the program counter and context switching takes place. In the ISR interrupt subroutine, all the statements that are written are executed, and after the last instruction it encounters a return, and the program it returns to the main program by moving the contents of the stack onto the program counter. So that is related to the working of an interrupt. Interrupts have priorities as well. You can manipulate the priorities. In this program, however, we will be just utilizing the interrupt capability of MSP430. I won't be changing the priorities of interrupts or manipulating those. We'll be just manipulating the interrupts, what it does in the ISR. In MSP430, there is a vector address for port 1 interrupt and there is a vector address for port 2 interrupt. But if the same address is used, if interrupt occurs on any of the pin of the port, for example p1.x will go to the vector address of p1, and p2.x interrupt will go to the vector address of p2. Now let's begin with the program. Our project, in this project we need to visually see the interrupts, so we'll be using 8 LEDs for that. If you have made the LED pattern PCB, then you will be having a shield kind of circuit with you. You can easily interface it with the launch pad and use it like normal Arduino shield. So anyways, if you have not done that, you can use the good old breadboard. Connect the ports to resistor connected to the positive of LED, the negative of LED grounded. Then once you have done that, you have to connect the switches. We'll come to the switch part later. First we'll start with the program. We'll follow the same old procedure: file, new, project, CSS project. You have to give the name, the chip. I'll be using G2553 MSP430 G2553 for this. It has two ports, two 8-bit ports, port 1 and port 2, with various other features like inbuilt temperature sensor and so on. So you have to select an empty Grace project, give the name and finish, and the project will be created. I have already created the project. It is named interrupt. In the project explorer, you have to expand the project you have created. It should be active and in debug mode. You have to open the main.cfg, that is the configuring file for Grace, and main.c file, in which you will be writing your main program. First we'll configure everything. So double click on main to focus. Now in this program we won't be using any oscillator like we did for the 1 second delay using Grace, in which we used a 32 kilohertz crystal to generate a precise 1 second delay. Initially I was thinking of giving a delay using the timer section, but then I rejected the idea. Okay, now we'll go back to the Grace device overview. Now we are not initializing the oscillator, and so we don't need the timer as well. The watchdog timer is a different story altogether. You need to stop the watchdog timer because in this program we don't have a need for the watchdog timer. If the watchdog timer is running, then it will reset the program after a particular interval unless you reload its count. To stop the watchdog timer, you have to give the password, watchdog timer password, and the watchdog timer stop bit to the watchdog timer register. All these things are done by Grace. So it is an excellent peripheral initializing GUI provided by Texas Instruments, and it is a part of Code Composer Studio. That is the latest version. I don't know about the previous versions. Now the ports, since we'll be driving LEDs, we need ports. I'll be using port 1 for driving the LEDs, port 1 8-bit port, P1.0 to P1.7, all of them I have configured as output, which is by default. So whenever you reset your microcontroller MSP430, in our case, the ports will be general purpose output. Then the output is low by default. This is to save power. If the output is high, maybe the power required is more, but I'm not sure. But then it is set low by default, that is true. Pull up or down register enable is not available if you set the port as output. That is obvious, because for output you don't need this functionality, unlike other controllers like like, no, all controllers are like this. Okay, interrupt, since it is configured as output, you don't need the interrupt enable register as well. Port 2 I'll be configuring for interrupt, so I'm making the port as general purpose input. I'll be giving 6 interrupts on P1, P2.0, P2.1, P2.2, 3, 4, 5. I have pulled up the registers. You see, I told you regarding the push button, I left it for this concept. You have pulled up the register, that is the output is set high. Your port 2 pin is 1, logic is at logic level 1, and in the interrupt enable I have selected falling edge. Falling edge means high to low. So whenever you want to give an interrupt, you have to ground the port. That is why I have used 6 push buttons. To one side I have connected the port 2 pin, to the other side I have connected ground. So whenever you push the button, it is grounded and the controller will receive an interrupt. So this was regarding the push button setup. You can develop various other logics. Each mind is different. So port 2 is enabled for interrupts. Now we will view the interrupt handler. So we'll click on view all interrupt handlers. We'll select the port 2 as we will be manipulating the ISR of port 2, and click on this open interrupt vector file. This will open the interrupt vector underscore init.c. In this file it is clearly written that you have to write the code in the user code start and user code end. You have to write the code between these two comments, else all the comments will be overwritten when it is regenerated. So we'll follow what they say and write it inside the start and end. I have declared a long variable I. Long, it is 16-bit. The registers of MSP430 G2553 are 16-bit. They can be used as 8-bit, but I am using a long so that the delay I can produce is more. The maximum count of I is 0FFFFH 64K approximately. Okay, now we'll go to the interrupt void port 2 ISR. We have defined the pragma vector, that is the vector address of port 2. Using pragma you can define the vector address of any ISR. So in this ISR the function is defined by Grace. I have written 5 statements, if statements. The if logic is P2 IFG and bit 0. You see, when you give an interrupt, you need to know that you have got an interrupt. So if you want to check which pin of that port gave that interrupt, that facility is provided in MSP430 and all the controllers. So P2IFG or PXIFG for that matter, where X corresponds to the port number, is a 8-bit SFR, special function register. Each bit corresponds to the pin of the port that the SFR belongs to. So P1 IFG will correspond to the pins of port 1 and P2 IFG will correspond to the pins of port 2. I have ANDed it with bit 0, 1, 2, 3, 4, 5 to check the bits. A and 1 is A. So bit 0 means D0 is 1. So D0 and D0 of P2IFG is P2IFG D0. So when P2IFG D0 is high, this if statement will be executed. And when will it be high? It will be high when there is an interrupt on the port pin P2 port pin 0. Similar is the case with the other pins. Now I'll explain the logic that's written inside the if statement. In order to visually make it apparent that which port pin had given the interrupt, I'll be making the LED corresponding to that pin high. You see, if push button 1 is pressed, then P2.1 will get the interrupt, and in that if statement I have made P1.1 as 1, so that will be 1. So whenever you press the button, the LED corresponding to that button will glow. Now there is one important note given in this grace comment, that user must explicitly clear the port interrupt flag before exiting. So you have to clear the port interrupt flag. I'll give you an example. This was given to me by my professor. I was sitting and he told me to sit down. I was like, what is he trying to say? Then he said that if you are sitting, I can't make you sit down, so I can make you stand up. So he could have said stand up and I would have stood up, but he said sit down. So I can't sit down when I am sitting already. So similar is the case with this P2IFG. If the P2IFG bit is high, then how will you come to know that interrupt has come again? So you have to clear it so that it becomes high once again when the interrupt comes. So that you have to do manually, because Grace is not doing, the compiler is not doing for you. After that I have written a for loop for a software delay. This is a software delay. It will keep on incrementing I 60,000 times and it will create a delay. So that is all about the ISR. In the main.c file, mind you, all these files can be easily opened using the project explorer. Main.cfg, if you want to open, you just double click on the file. Main.c, if you want to open, you can double click the file. All the header files that are included in this you can open using the project explorer window. This outline window is also interesting. If you click on main.c, you will see the header file explicitly mentioned, the grace.header file that is mentioned, and the main function. So if you want to see the header file, you can double click on the header file and it will open the header file for you. In the header file, all the constants are defined. So if you want to use any constant that are defined in the header file, you have to include it in the main program. If you don't do that, you will get an error that this constant is not defined. So you can make your own header files, name it .h and include it. That becomes a header file. So as you can see, bit 0, 1 and etc. are defined in this header file. There are various definitions in this. So let's get back to the main program. In the main program, I thought of copy pasting the previous project's source code. In the previous project, we did LED patterns. I have copy pasted that code as it is into this main program. So normally it will be showing those patterns, but whenever it gets an interrupt, it will stop the execution of that program, complete the instruction that is being executed, and it will go to the ISR. Context saving will take place, context switching will take place, IR execution will take place, then it will resume back to the main program. So that is the working and of this main program. I have told you few things about hardware interrupts. Now there are software interrupts as well. I won't be going into the software interrupts part now. So what we will do is we will debug this. Proceed. It says loading complete, code size 1584 bytes, data 4 bytes. So your hex file that is generated is 4 bytes, and the free version gives you 60 KB memory. It allows you to write 16 KB into the flash memory. That is more than sufficient on our level. My Code Composer Studio was licensed for 90 days. It expired today, so I am using the limited version now. But as you can see, Grace is working and all the functions seem to be working. I have not really seen all of them till now. Maybe in the next tutorial I'll elaborate on that. So that is all for this tutorial. Thank you for watching this video. If you have any doubts regarding hardware interrupts, how to give an interrupt, switch debouncing, yes, switch debouncing. When you press a switch, mechanical switch, due to the mechanical action there is a recoil. The switch will have a spring like action. It will move up and down. There will be contact made. There will be the contact will be broken, so the port may get re-triggered. So that is debouncing. Switch debouncing, it can be avoided by using flip-flops. I'll be talking about switch debouncing maybe in a separate entry, blog entry. So that's all. Thank you very much. Have a nice day.